Hello, everyone. I'm really happy and excited to be with you today. And I'm with Tarek, who is,
Hello, everyone.
yes, just came back from New York.
Yes.
Yes, so we'll be waiting as usual for 3, 4 minutes for people to join. And then we'll be talking about modules and building modules together. For the people asking for the links of the previous sessions, the team will be giving you all the links in the chat, and we will be also giving all the links for YouTube and LinkedIn by the end of the session. And in all cases, even if you don't find them easily or the link doesn't work for you, reach out to us, and we'll be happy to provide them in private. All right, I think we can get started. We got a few people joining us. So, all right, for the session of today, we're going to learn together about Terraform modules. And the most important thing is we are going to build together modules. So, just a brief introduction about me. I'm an engineer. So, I'm Chafik. I'm an engineer with 16 years of experience now and been building infrastructure my entire career. I'm the founder of Brainboard. I love talk technical aspects because I was also the former CTO of Scaleway, which is a European cloud provider. It is, as far as I know, the third biggest cloud provider in Europe. So, brief also introduction about Brainboard, what we do at Brainboard. Brainboard is a solution to visually design and manage cloud infrastructures, which means it allows you to build your infrastructure on a designer. It will generate the Terraform code for you, and it allows you also to create an ecosystem around the management of infrastructure with best practices and infrastructure as code in mind. In all cases, I'm gonna do the demo today with Brainboard. You will get the chance to see how it works, how I use it, and feel free also to reach out to me if you want to learn more, or if you are interested in any aspects of Brainboard. I will be happy to talk. Um, Also, what we do at Brainboard, our goal is we are engineers, and Brainboard has been started by engineers, and we wanted as to help how we wanted to help the community by reducing the learning curve of the cloud, because we know that when we learn and we work on cloud infrastructure, we have a lot of learning curves to go through. For example, we need to learn the cloud products and services. We need to learn the tools. We need to learn the best practices around them. We need to work to learn how to work within a team and so on. So we want to help the community by providing free trainings and free quality trainings. You can find a lot of Terraform trainings on the internet, and this is really great. The community is doing a lot of good things. I love it. What we do, like we take it to the next level. We go deeper into some aspects and make them simple. And so we share our understanding of the technology, how we see the best practices, the learning that we have, and we want and we love to stay connected to the community and bring this value to all of us. And the objective of this session today is to learn about everything about modules and how to use them. When I say modules, Terraform modules, because like when we work with Terraform, Terraform is now the most used language or framework or whatever we call it to build infrastructures and to provision infrastructures. And there are a lot of people excited about it. And we realized that the community need constant refreshing about how to keep building best practices, how to move from simple aspects into more advanced, how to build on top of that. So we created a series of videos. The first one was about the Terraform basics. Then we zoomed on the variables, and now we're gonna go to the modules. We go deeper in the modules. So what we will do together today, what we will learn, we're gonna go through the definition of the modules, how what they mean in Terraform. But the most important thing, we're gonna build together some of the modules. I picked two cloud providers, Azure and AWS. I know that we have different people that come from different backgrounds that use different cloud providers. For today, I selected two, Azure and AWS, and we do the workshop on them. We're gonna also review some of the most used community modules, how they are built, how we build them, and also we shared about the best practices. And by the end of the session, I will show you also what we have done at Brainboard to allow you to create your own catalog of modules and how you can manage your infrastructure in a confident and secure way. All right, so let's get started now about what the modules are. All right. So in a nutshell, a module is just a container of resources that are used together. It's like a packaging or a library that contains all resources. And think of it like it's the Docker for an infrastructure. And I had a discussion with Jeremy, the CTO of Brainboard, before starting the talk. We were discussing about, is it more like Docker or like a library or a package? I think of it as more Docker because it is more related to the infrastructure, and because it's a packaging of resources in a unified way. And also, like when we talk about the modules, something really important, Terraform knows only modules. So when you are working on Terraform, even if you do not specify explicitly that you are working on a module, you are working on the root module, is always there. And the second part is, as it's the module is a container of resources, to see what's inside is what the Terraform actions allow you to do this. For example, when you do Terraform plan, apply, or destroy, it will show you what are the resources inside the module, and it will give you also the path to these resources. You're going to see them under the name of the module. We're going to see all this together. And the third part is, keep in mind that in the Terraform code, the module is just like any other resource. It's kind of black box. And for example, here I took a screenshot of the definition of the module. When you use a module, this is how you define it in the Terraform configuration. And it's for the user, is just one resource that encapsulates a lot of resources. That's why, and this is for AWS and this is for Azure. It works the same way for all cloud providers. This is related to Terraform. And we will see later what's the difference between a resource and the module, how they are combined. And also there are like subtle information that we need to look at and be careful when you use modules. So now let's, as we are talking about modules, now let's zoom where the modules fit within the cloud infrastructure. So let's see the resources. In Terraform, resources, it's a block that contains the provider, the type. It could be, for example, the provider or an alias or something that you can put variables in it. It contains cloud information about all the parameters and how you configure them. It contains meta argument. This is pure. This is related only to Terraform. Like if you want to create a count, you want to create 3 resources of the same type, you want to create loops and so on. And there is post deployment. This is called provisioners. Like you can trigger actions when the resource is created. The resources accept variables, so you can put variables. I put it input in general because the input can be even local to the resource or to the architecture, or variables that are used more globally. And it can produce output. And these variables and output are part of Terraform. So you can define variables and you can also define the output of the resources. So now these resources, they are combined together to create a module. So I took 2 screenshots for AWS and Azure. And the anatomy of the module is it contains a source, which means where I can find the module at the execution time, where Terraform can find the module and use it. And we're going to see all the different sources. On purpose, I do not go to the very basic information. I try, then the session of today is focused on like a hands-on session more than just theory. So I give you more the information related on how you build modules and use them. You can specify the version, and this is like tricky part because the version is not always an accepted argument in module. For example, it's only accepted when you use the registry of HashiCorp. And then you can put the configuration parameters, and we're going to see them. And you have a meta argument. So as every resource has its own variables or may have its own variable, once you put them within the same package of the module, you will be having a unified input, unified variables for all these resources. Then you can dispatch and say this variable, this resource use this variable, another resource use another variable or not. So, but the module is seen as a resource and accept one unified input. And of course, it produces one unified output. And very important information here about the modules is that this output of the module is extremely important. We're going to see it because it may and it can be used as an input for another module. So, and the cloud architecture, simply put, is the combination of modules and resources. So you can, in the same architecture, you can create building blocks that consists of like repeatable patterns, and you put them in modules, and more specific resources, and you keep them as resources. You have no need to put them in modules. And again, for the infrastructure, it's going to be like global variables, global input, and global output. So like there are kind of layers. You have the resource, then the module, then the infrastructure. So now, the most important question when you use the module is why or when. There are different questions about the module. So yes, the first one is, why do you want to use a module? This is a very important question that you have to answer internally because, you need to, like the way you think about the module will shape how you build them, how you distribute them, and how they will get used. The second part is also like how related to how you will use the modules. And the second question is, what do you want to package? as a building block. And this is like a cursor that you can put everywhere, depends on the strategy that you have. A very important information: don't get drunk of modules too quickly, because when you start learning the modules and Terraform, you realize that they are powerful and you can do a lot of things, and it allows you to not repeat yourself. But it should reflect, the module should reflect your maturity on infrastructure as cloud. And even HashiCorp recommends moderation when using modules, and we're going to see the best practices in all cases. So now, as we are introducing modules and talk about them, maybe you have used them or tested them or seen them, and there are like the community modules that are open to anyone to use, and there are private modules that you may develop within your company and you use internally. And there is a very important differentiation between both of them that you need to be aware of, and it's really tricky. The community modules are stack-based grouping, are based on like grouping resources together. Like you can find VPC, DB, virtual network, and so on. So they are based on the stack. I want a network stack. I want a computing stack. I want an authentication stack, and so on. But within your company, maybe your what suits you the best is not stack-based module, but more producer and consumer. Because within your company, you will be creating modules that will be used by your colleagues, by different teams. So that's why you need to think about it this way, like what are the building blocks that I need to build within the company, or what are the stacks that I need to package to a team A, team B, or maybe internally. One of the examples is, for example, you have a packaged application that contains all the resources, compute, networking, database, the VPC, and so on to create the application. And even if you check the website of HashiCorp, in most of their trainings and examples, they are more producer-consumer oriented. For example, you can find how to build an S3 static website, how to build a database web application, and so on. So this is a crucial difference between both of them. And it allows you also to bring this maturity. Maybe you can combine in some parts. If you are like a network team, it's much better to think about it as a stack. And if you are DevOps or cloud architects servicing different teams, maybe you need a producer consumer model. So there is no, I'm not religious about this topic. It's just giving you more information about how to think about modules before building them. So yes, these are like things that you need to keep in mind when you work with the modules. We're going to build together some modules. The first one is, as we are, the module contain unified variables. You need to understand first the difference between locals and variables. You know, the locals, and if you need a refresher about all these aspects, please check the session, the first and second session. So the locals are internal, they are not exposed. If you define locals, they would not be a part of the configuration of the module. But if you configure variables, you have the possibility to expose them and put them as required. And as talking about the variables, you need also to make clear what are the required variables and what are the variables are not required. And keep in mind as well that if you do not put default values on a variable, Terraform will consider it as required. So you need to provide the value at a certain point to be able to provision the infrastructure. And also, like one of the tricky points that I've seen in different base codes and working with different people is how to define the output. Because you can define the output of every resource, literally, or you can limit the output to only what you need. So it's this, the definition of outputs is directly related to how you or your team will use the module. And again, is it like stack based or consumer producer? If you are stack based, so you are agnostic, you tend to provide more output because you do not know how it will be used. And if you are in the producer consumer module, you need to be more restrictive and only provide outputs that make sense for the consumer. And also the output of a module can be used by another as an input for another module. So this is also one of the things that you need to think about when you build modules. Like you provide the possibility to combine modules together and create these channels of input output between modules. Also, you can nest modules. For example, you can call a local module in another module. You can create a different combination of calling modules. And this is what HashiCorp call child modules. So when a module calls another module, it will be called as a child. So, and now we're gonna build together a module, and it will be when we build a module. So we're gonna create a module, then we're gonna push it into Git. Then I'm gonna import it and show you how it works. So this is the interface of Brainboard. Maybe those of you who never tested the Brainboard before. So this is the interface, and you know, the module is cloud architecture. We'll be building for the use case of today. I will be starting with Azure. Here I select the cloud provider, so I have the complete resources of available at Azure. That also contains all the cloud. I can combine different cloud providers in the same design. And for the use case of today, we're going to build a web application. And this, we're going to package the web application as one module. Then we can go slice it into different modules and see how it works. So I start with putting a location here. All right, I can keep it in the US and make it bigger. So, and I use Brainboard because it helps me write the Terraform code. I don't need to write the Terraform code. I design and we see together the architecture of the module, and we have the Terraform code generated. It's much more easier. So here I gotta add a resource group. And for the resource group, I'm gonna call it default. And you see the Terraform code is generated on the right as I type. And I have here in this configuration menu all the parameters available both in Terraform and at the cloud provider. Here I call it default as well. Default resource group. All right. Inside the resource group now, I'm going to add, I will start with so DNS zone. I'm going to add the DNS zone here. All right. And for the name, I'm going to call it trainings at brainboard.co. Let's say this zone will host this information. And I keep the default tags here. You have the possibility to configure all the parameters. For the use case of today, I'm going to keep the minimum parameters to be able to create the modules. Then we can go through creating variables and so on, and we can go deeper in the configuration. So, and now I'm going to add also a DNS record, record A. Yes, I put it here. All right, in the record A, I'm going to call it record A. Record A. And for the TTL, give it 300. And for the zone name, I'm going to use the zone that I already defined. Yes, this one. And put, and put the name here. All right, and I keep the configuration as it is. So maybe for the record, I'm gonna add an address here, 183.18.19.25. This is a valid IP address that serves my record. And this is it. So here, And as you see, so you have the rows here that Brainboard created when I create the resources. I linked them together, so it created the record. And you can see the configuration of the module is just resources that are defined together. So here, the Terraform code. I go ahead now and I create the web application. I use Linux web application. Yes. I'm going to add it into the design. So Brainboard detects the interaction between components and detected that I've added this web app into the resource group. And I call it Linux web application. And call it resource name and name it default. Yeah, for the service plan, I'm gonna create a service plan and link it just after. And here I can say the site config is always on, and I'm good with my configuration. So now I'm gonna create the service plan. So here it's service plan. Yes. All right. And for the service plan, I'm gonna again like call it SP OS type Linux. And feel free, if you are following me and using the same example, feel free to use the example that works for you. And if you are an Azure user, the one that you are used to do. And for the SQ name, we're gonna use just F1. And that's it. For the parameters, I keep them like this. And the tags, I keep them like that. All right, maybe here I'm gonna call it the default service name. All right, so and now in the web application, I'm gonna specify that the service plan ID is service plan. Yes, I have from the suggestions and I link them together. Okay, which means how you read the information, the web application uses in the service plan ID, the service plan here. All right, we have a good start for our application. So now I'm going to add a database server for my application, MS SQL. All right, I'm going to add the server. Okay, I add the server here. And for the name, okay, MS SQL server. Okay, for the default, I put the version 12.0. And for the advanced configuration, it's better that I use variables here. For the login, I'm gonna use a DB user. And here I'm gonna use admin password. And as you can see, Brainboard detects automatically that I'm adding variables and add them, which is just great for my use case. You can configure the different parameters. These parameters are exactly the same parameters that you find at Terraform. They are simplified. So when it's a Boolean, I have just a Boolean. When it's a list to choose from, I have a list of suggestions and so on. So I'm good with my server. So now I'm gonna create the database. Yes, which is here. All right, I have the database. And for the name, I just call it DB, and the resource call it default as well. And for the server ID, I'm going to use the server that I have just created. So yes, this one. All right, and this is it. This is all the information that I need from my database. I can create geo backup, enable it, and so on. We keep it simple for the use case that we have now. All right, perfect. And now I want to add maybe a storage account into my configuration. So I start first with creating a storage account. I'm gonna make it a bit bigger here. All right. Storage account. I add the storage account. Yes, it's in this resource group. And in the account here, I'm going to put standard, the name storage account. And yeah, the replication type, we put it LRS. All right, so I'm good with my configuration. Maybe if I want to enable, I'm used to enable the HTTP traffic only, so you have the possibility to enable it. So you have all the parameters, and I'm good. Still, I'm gonna put the resource name as default and save. Don't worry, maybe you are seeing the resources piling here in the same main.tf. I will show you how we're going to slice them into different files that matches exactly what I want to do. I finished the configuration that we can go through this. And now here I create a storage container. That's container, yes. I create storage container here, and yes, I accept the default. All right, I call it storage container. And for the storage account name, I use the account that they have created. And add dot name. All right. And this is it. All right, maybe. Okay, we keep it like this. And now I'm going to create a blob, storage blob here. Yes. All right, and I will configure this storage blob to use both the container and the account. So here of type block, and for the container, I'm gonna call it storage blob 1. And for the account name, I will be using the account that we defined. Storage account default, yes, and dot name. And for container, I use the container that I defined here, which is this one, and use the name. This is all the configuration I need for the blob. All right, I think we are good with our configuration. So here I created, we can say, a small version of my web application. For example, sorry, here I have all my resources. I can add an icon if I want to internet. If I want to depict internet here and say, okay, I want here add internet and link it to the record A, that the traffic will be coming this way. But this is the representation. It hasn't the equivalent of Terraform code. And I have here my files. So to validate that the code I've created is, I can deploy it, I do a Terraform plan. So here in Brainboard, you can do different type of actions. You can do Terraform plan, apply, and destroy. And also when you build modules, make sure that every time you do the plan, when you do modification, yes, this is a very nice catch because I didn't define the variables. The DB user, yes, they are defined, but they have no value. Here I put string. Yeah, in Brainboard, you can define variables at different levels. You can define locals. And when you define a variable, you have all the parameters that are supported by Terraform. So you don't need to guess. And for example, for the types, it gives you all the types supported and so on. And for the default value, or call it, please change me. You can flag it sensitive, all right? And for the user, it's a string as well. And we call it, for example, admin user. All right. So when I add these variables, you can check them here in the variables.tf. Yes, this is the block, the Terraform block generated. And now if I do a plan again, yes, I do the plan again, I will see what will happen to my infrastructure. Yes, so now all the Brainboard is converting all the design I've created into, yes, can only consist of lowercase letters and numbers. Yes, this is for the storage account. I love it, these kind of errors, because it allows us to see also how, when we build, what are the type of errors that we have and how we correct them. Now I'm going to put it lowercase and trigger another plan. And hopefully this one will pass. And once the plan is green, it passes. We're going to go to the next level and show you how we slice the files, then we do the pull request. All right, this is also lower in name, lowercase, and the storage container. Storage container here, yes. Azure is really picky about the capital letter, lowercase, and so on. They do not accept any value that is not exactly as they want. All right, so here I will be having the plan hopefully passing. Perfect. I have my plan green now. All right. So if you are building infrastructures and you want to deploy it, you can go ahead and deploy it. If you want to check that the infrastructure can be really created, you can click apply and create it and deploy it. But for the use case of today, we can say the plan is enough. All right. So everything is green. That's great. So now I'm going to package this architecture within a module. But first, I want to slice the different resources into files. I want to put the DNS record and zone in file, call it DNS. All right. And Brainboard will generate this file, dns.tf, that I can see it here. It contains the two resources that I grouped together. I'm going to put the web application and the service plan in a file called app. Okay, I check the app.tf. Yes, it contains these resources. And now I'm going to put the database, the server and the database in the same file, the same group or file, call it db. And check again, now the db.tf contains, yes, these two information. And I put all the storage component into a group that is called storage. All right. Yes, and now my main.tf contains only the resource group. And here I have the storage, yes, that contains the three resources that I have created. So now I want to put variables to my to my resources. So the first one, for example, I can change the zone. Maybe here for the name, I'm going to put it variable.zone name. And you will notice that all these variables that I will create, they will be the input of the module. So here I save it. What I can put as a variable as well is here in the web application, I can keep it as default. Maybe in the server. All right, I already use, yes, here, for example, the version, I call it variable.server version. All right. So now for my variables that I have created, zone name, and I give it a type string and default this value, and as description, the default, the name of the DNS zone. And for the version, I said 12.0, and I put it here, the default version of the server. Okay, I check again that everything works as expected. We changed the DNS. Now it uses a variable, which is here. I changed the server for the, I changed, yes, this, the database, I changed the server version, which is now server version. And now I will do a plan again to see that it still works. Then we do a pull request. So right after this action, I will do a pull request into my Azure DevOps repo, and then I will import all this architecture as one module, and it will show you how it works. Yeah, the server version must be, yes, got 12. All right. So here we need to specify, okay, you need to code it to be able to be considered like full string without interpretation. And here I'm going to do again a plan. And this is like, this is the way you will be working with modules. Modules are architectures. You build them in a purpose, and then you distribute them, and you just use them. All right, so the plan passes again, which is great. Perfect. So now I can go ahead and create here. I'm gonna, oops, sorry, I refreshed my entire, yes, page here. Now I will create a pull request to, I'm gonna configure my Azure DevOps subscription and create, yes, Brainboard, and call it training modules section. So now I will do a pull request into my Azure DevOps and import it again into Brainboard. All right, here is the link. So Brainboard package all the files that we have seen together. Here are the files. They are packaged and put together. And now I can just, yes, complete. So I merge. This is just an example. All right. And now I have the URL here. And I will tell Brainboard that I want to use this module as this architecture as a module. So I'm going to call it here web app module. And I have the possibility to import from different sources. For today, I'm going to give the URL and just remove the beginning because this is Brainboard will edit automatically. I'll use from the credentials that I have Azure DevOps and the main, and I'm pretty good now. So now I import the module. All right, it has been imported. So before doing any modification to my infrastructure, I create a new version. Here I call it, for example, initial commit. All right, so Brainboard allows me also to track any modification to my infrastructure. So now I delete everything. Okay, and I will import this module here. So Brainboard fetches it automatically from my Azure DevOps subscription, as you can see here, and put the source in the right way. And in the optional variables, here are all the variables that we defined together when we created the resources. They are now part of the same block. So here, for example, for the version, I'm going to do another version. I keep the same version just to give you an example. Another zone name, deep user user one. Okay, and I keep the others. All right, so when I save it, here is the definition of my infrastructure. Now, as I told you, like the module is black box. I do not understand what's inside unless I have the architecture in front of my eyes. So now I will do the plan to see what are the resources inside my module. So I'm going to do, again, a plan with this module imported. So yeah, this is also one of the things that you need to think about when you distribute modules within your team, how the user will consume it, what they need to understand or what they need to put as information to be able to use the module in a self-serve mode. So here is the information, and like now, Terraform within Brainboard did the plan, and you can see here it's a module. It's so the namespace is module dot the web app module name that I've imported, that the name I gave to the module, then the resource and its configuration. All right, and you can now combine different modules. Yes, I go back to the design. So now you can create different modules and combine them into the same architecture. And here, for example, when you import modules into Brainboard, you'll be creating your own, you can say, modules catalog. And for example, I want to add a resource group module. Okay, let's look for Azure. All right, for example, yes, Azure Gateway. So I just pin a module here and drag and drop it, and I can combine. So when I drag and drop it, I have the configuration of the module. It's okay. My mouse. Okay, now it works. So I have this configuration of the module, and I can create an architecture that is just a combination of modules. And I can also, of course, add resources here and add different information, and my code will reflect all this. So this is in terms of how we build the module. We split them into different resources. And if I go back, for example, now I create a new version, call it add modules. Now I'm gonna check out the first version where I had all my resources here. Yes. Now I can go ahead and slice them into different modules. So for example, I can create a new architecture for a module that contains only the web application, another module that contains only the database, and another module that contains only the storage. It's up to you to like set the limit. What is the limit? Is the limit the complete stack, the complete consumer in the producer consumer module, or I need to go into low level building blocks? So, and we can do the same quickly in AWS. For example, here I'm going to delete everything again and switch into AWS. And let's say we can create a landing zone in AWS as a module, and it will work the same way. So our friends for AWS will not get angry on us because we are talking about Azure a lot. So here I add a region. Okay, I can put a variable in a region as well. And for example, here I'm going to add the landing zone. I'm going to put a VPC. All right, and this VPC, I'll start with the variables from the beginning. For example, here I'm going to put CIDR block. All right, call it default VPC. Perfect. And now inside my VPC, maybe I can put different availability zones, or maybe one availability zone that contains different subnets. So let's put one and show you how now we use the loops like count, for each, and different functions to define multiple subnets. For example, here I'm going to choose, and of course, I can put everything as variables. So as a matter of time, I will be using a clear availability zone and region. So here for the subnet. All right. So this is interesting here. For example, for the subnet, I want to create 3 subnets within this availability zone. So here I can say in the count will be the length of variable subnets. So now I can create, with this one, I will add the variable that contains the subnets. And for the subnet configuration, it will be variable subnets and count.index here. All right. And you can see it here. Brainboard will add as a hint what the variables had been, what are the variables that are used as a count. And this is, for example, I can call it, these are public subnets. And now I will create a private subnets, for example. And I can do the same or not. Maybe this case for the private one, it will be different. So I'm going to put the value on it /24. And yes, and in the name, call it private subnet 1. And you can see here in the code that that has been generated that reflects what I want to do. So, okay. And now maybe I can add a route table, or I can add an internet gateway, for example, into the VPC. Okay, so yes, it has, the VPC has been detected automatically. All right, and it can be like this configuration, this, like I say, the beginning of the landing zone can be my module. I import it as one block, and when I put the variables, it's going to create as many public subnets as I have in the variable subnets that I define. It will create one private subnet and an internet gateway. So, and this is like I show you in Azure producer consumer module, and I showed you on AWS like a building block module. So for the time that we have, we can review some of the community modules to understand how they work. Before that, just wanted to share with you the best practices. For example, yes, for our to use modules. So these like best practices, it's not the complete list of best practices, but this is like the most important thing I went through personally when I started using modules, especially within the team. So the first one is I realized that it's really important to keep modules small because for different reasons. If you have a lot of resources and you are using a lot of modules, so when you do a deployment, Terraform plan, apply or destroy, you will, the Terraform refresh the state, it's going to take a lot of time. So you are going to suffer from this until maybe you have a CI, you don't care, you have the CI, you do Terraform plan, and when the CI ends, you have the output. But when you test locally, it's really important to keep that in mind. The second important information is to name outputs close to the original name of resources. For example, if you want to expose the VPC ID, just call it VPC underscore ID. If you want to resource group name, just call it resource underscore group underscore name. Maybe because when you do abbreviations, you may understand that these abbreviations because you work with infrastructure every day, but for maintenance or maybe for consumers, they need to understand what the variables, what the input are. The other very important aspect that you need to think about is that modules are used for as repeatable building blocks. It's not for edge cases. So avoid putting edge cases in modules because it will bring a lot of headache. If you have an edge case, just bring a module use a module that brings the first part and put the edge case as resources inside it. So don't put it in the module. And also start with the working MVP before complicating things, because module and infrastructure, especially now, it's organic. It's gonna live. it will get changed maybe faster than you think. Destroyed, created, things, yeah, the parameters may change. So keep it this way. Stay close to the MVP, then put, for example, advanced feature when you need them. Otherwise, keep it simple. I really love the KISS principle: keep it simple and stupid. And the last part, the best practice is please think about how to maintain modules while building it. We know, like what I've seen in the industry, that we need to go fast, to ship fast, deliver fast, and so on, and we tend to take some shortcuts, and it's going to make the maintenance complicated. Sometimes you just need to take 2-3 minutes to think about what we want to do, how we want to name things, what are the values that we need to expose, and so on. And it will save a lot of time and frustration for the people that will be using and maintaining the module. So now we can review maybe one of the few modules that are from the community. For example, I had, yes, here, this is the registry of the official registry of HashiCorp. So we worked a lot on Azure. So for the remaining time, I'm going to work on AWS. For example, the VPC has been downloaded 27.8 million. So it has been created by Anton Babenko. Hi, Anton, and thanks a lot for helping the community if you are hearing us. For example, yes, we can use the AKS module, for example, or maybe Lambda module. Okay, we're going to see both of them. All right. So here I take the Lambda module, and I will import it into Brainboard. It will be much more easier for me to inspect what's inside. So here I can import any Terraform code and call it Lambda module, just Lambda module. So now Brainboard will pull the repo from GitHub, will draw the graphics of the components, and we will have the code to inspect both how the design looks like and what the generated code is. All right, so these are all the resources. Okay, I close this part and make this one bigger for the code. So here, yes, this is, for example, one of the most used modules. And as you can see, there are a lot of resources. And I think, yes, they are grouped into few files. For example, all AM are into one file, which is really good here. And you can see this definition related to only to the files. And as you can see, for example, there is a local called role name. And if we open the variable, the locals, yes, it's defined here. And it may use a variable called role name. So when you check the public modules, they contain really a nice also suggestions and hints on how you can use variables, locals, functions, and so on to be more specific on the use cases. So and yes, keep in mind that these locals are not the input of the module. So that's why they put a variable called role name, and in case that this variable local is not defined, it will use this part. Otherwise, it will be null. So here, yes, here, if I open the variables, so you can see all these variables. These are what you can set as an input for the module to be able to use it. And so now if I want to use this module, if I want to import this module as a module, so I'm going to take the URL from Git, and now I try to import it into Brainboard. I call it Lambda module. All right, so, okay. That's perfect. So this module, when I import it here, and I look into the optional variables, you can see all these variables here are what you can find in the variables that I have imported from the modules. So policies and so on. So everything is defined here. They are put into, this is the list that you can choose from. And so, yeah, and you see, even when I import a module, a community module, in terms of the design, as it contains a lot of functions and a lot of values and variables, sometimes it's not even obvious to see the relationship between the resources, which one is using another one. So that's why you need to keep modules simplified. And for example, we can look at AKS, how it looks like. All right, we can, yes, take this module here. Let's see the design of this module, how it looks like. Okay, AKS module. All right, this is a very interesting use case. For example, here, this module that I've imported itself contains other modules. For example, here, Fargate profile. This is another module that contains also parameters. Some of them are pre-configured, as you can see. And so, which is like you import a module that contains different modules. And I think this module is a local one. Yes. So yeah, like be careful also when you import modules, when you have nested modules, if they are accessible. So if, for example, let's say this module is located in another Git, so make sure that you have access to the other Git to be able to pull all these modules. Otherwise, it will not work. Yes, this is a Fargate. The cluster itself, this is called a cluster, but the resource is a security group. So yes, here is the configuration. And it uses also another group, for example, the managed group. So managed groups is a module itself that contains all the resources, and I can just interact with them and create them through the configuration here that you see. All right, so, and you can, I invite you if you want to understand, if you want to see the architecture of the modules that you are working on and how it looks like in terms of design, what are used and so on, feel free to use Brainboard. Or if you need any help on modules, reach out to us. We will be happy to help. We pay it forward to the community. We learn from the community, from free courses, free materials, and so on. So we are happy to help, and we pay it forward. The last slide that I had, actually I had few slides. This one is about hosting modules. And as you have seen here, I had the possibility to define modules, create modules here, and do pull requests on my Azure DevOps subscription, which means I can host modules into my Git. The most used locations are Terraform registry. This is and this is very important. When you use the registry, you have the possibility to specify the version, which is not it's an option that you cannot have when you use Git repositories. So when you use Git repositories, you need to specify the reference. Like I can show you this in Brainboard. For example, here, the module I created, it comes from Git. So here, if I put the version, for example, 1.2.3, so Brainboard now will add automatically this stuff for me. So this is what you need to do to specify either version or branch that you want to use of the module. So this is like the workaround of the versions. The most used locations also are local path, and we imported the AKS module that contains local path. But also, surprisingly, you have there other ways also to host your modules. So you can put them in S3 bucket. But when you put them in an S3 bucket, it's not easy unless you have a CI that will take them from the execution and put them into a bucket, and you will be able to import them. But you can use a bucket. You can also use a zip file over HTTP. Like you have an HTTP and zip file, and you can use it as a source. It's a valid source. For example, if you want to just make temporary module available for a team or a colleague or anyone that want to test it, they can. It's doable and easy to use. And when, a specification about Git repository, any valid Git repository can be used. Yeah, so you can use GitHub, Bitbucket, GitLab, any valid Git will be used. So this is the most used community modules that we've seen together. And before the last slide, so this is the last slide actually, which is about how you manage modules within the team. Really don't put too much magic in a module when you work within a team, because like either you will be the bottleneck, everyone will be reaching out to you to explain what you have done and why, or people, they will get just nervous by maintaining modules. They are supposed to be building blocks. So you are supposed to be an enabler when you use module. Keep this mindset. And I personally like the Python Zen. Explicit is better than implicit. So if you have the possibility to explicit what you do, the naming, the variables, and so on, put it this way, it's much better. And also, like, provide variables that make sense for the one who will be using the module, not your own logic. Maybe for your logic, you want to name or put different variables that you understand, but it's better that you respect the end user and put what makes sense to them. And also, like when you create a module, this is a very important aspect. You need to understand if you create new resources or you use an existing one. For example, I package an application, but I want to use an existing shared VPC. So I need to use data sources in the module and not just a resource to create a new one. And the same in Azure. For example, I want to create a module that contains resources that need to be hosted within a resource group. So don't create a resource group, just use data. It's supported. And also, like how to handle the versioning of the module. So do you want to pin modules or do you want to keep latest? This is important when you distribute modules within the team. If you keep it latest, so don't be surprised that the infrastructure may change when they use the module, because they are always bringing the latest changes. So if you want for security audits or for an approved infrastructure for PCI DSS or any other highly regulated environment, I suggest that you use pinned modules. You control what is deployed, and you can prove to the auditor that what you have in the code is exactly what is deployed. And also, something that I personally like when I work within a team is to keep the modules open to anyone to contribute. This is how you can you incentivize people from different teams. Like they use the module, they realize that there's something missing, a variable missing, something not clear, so they can contribute, they can change it. Because Terraform is an open source, so it's better that we keep this mindset when we work within the team. And also, two very important aspects, the last two ones is, the first is how to validate modules and how to use only the valid modules, because anyone can bring a module and use it. And sometimes, so you need to, especially if you use open source modules, you need to validate them, inspect, see what's inside. And not just in terms of security, but also in terms of cost, because when you create a lot of resources, you will be paying for these resources. So just be careful, because even if the security guys will be nice with you, I don't think that people who would pay money for the non-used resources will be happy. And the last point is, and this is a very important one, is how to manage the credentials if you are in the CI. Because especially if you host your modules in a Git, for the registry, it's much more easier. For Git, you need to find a way to give the way to the CI to pull the modules, give them the right, and deploy the infrastructure or do the plan or whatever you have in the CI. So this is like you need to be aligned with what you have when you work locally, when you are building modules, vs what the CI can do or not. And one tricky point also is like when you use modules from a different repo for which you do not have access. So you need to think about all these dimensions beforehand, because you will get like kind of problems that you may not understand at the beginning and just related to the credentials and how they are used in the CI. So that was really great to see you today. And this is like the first session in September after vacation. So again, if you have any questions, just reach out to us. I will be happy to help. And stay tuned. We will be doing other sessions, building infrastructures on different cloud providers, and always with a big pleasure to see you again. Have a great day or evening or morning, and see you in another session. Thanks a lot and goodbye.